Okay, here we go with the Algebra B Unit 8 test review. These are the test topics, 1 through 9, so you can observe that as necessary. And these are the topics that the video will discuss. Okay, so we're going to start with zero product property and x-intercepts. Use the zero product property to find the roots of the quadratic function. Keep in mind that when you see zero product property, okay, that means two things. It means set equal to 0, and then it means factor. Okay, so the method that we use for factoring the most is your generic rectangle and your diamond. Keep in mind that the x squared value, 2x squared, always goes in the bottom left corner. The negative 15, or the constant value, always goes in the upper right corner, and your b value, or your middle term there, always goes in the bottom of the diamond. All right, so that's the setup of the factoring. Then we multiply those two together to get negative 30 x squared, and now we ask ourselves the question, what can we multiply that gives us negative 30, so that when we add, we get negative 7. So think about that for a moment. And what it ends up being is a negative 10x and a positive 3x. Together multiply for negative 30, together add for negative 7. I knew the 10 had to be the negative because the 7 was negative. I fill those into my rectangle, and then I complete the outside of my rectangle to get my factors. So I end up with x minus 5 equals 0, and I end up with 2x plus 3 equals 0. So x ends up being 5, and x ends up being negative 1.5 when I solve those. And those would be the x-intercepts of the function. Remember, roots, okay, x-intercepts. Completing the square. So we're given a quadratic function. Use completing the square to rewrite the following in quadratic and graphing form. This could also be called vertex form because it tells us the vertex. We have a process for this. I gave you a formula. Just like we did quadratic formula, ax squared plus bx plus c in standard form. For completing the square, we're going to have a, okay, x plus or minus b over 2. We'll just say plus, sorry. This should work itself out. All right, so x plus b over 2 squared, okay, plus c minus a b over 2 squared. So if you use that formula, it'll always work. Or you could go back to the way that I showed you originally, which is to take your b value divided by 2, which is minus 3, square that. So 3 squared is 9. Okay, 3 squared equals 9, but I don't want 9. I want 5. So what do I need to do to get to 9 to get 5? I need to subtract 4. So there's my graphing form. Now the vertex is always the same in graphing form. It's always the opposite of your h value and then your k value. This is h, this is k. So the vertex for this particular quadratic will be 3, negative 4. Moving on, we have exponential growth with compound interest. Chuck invested $2,000 in his business, Chuck E. Cheese. The business increases his investment by 9% per year, compounded monthly. Write an equation to represent this situation. So the big thing here is that it's compounded monthly. All right, so just our y equals ab to the x isn't enough, okay, for this function because of the fact it's compounded monthly. I gave you a different equation for that, okay, which is the equation of an investment. All right, it's similar. All the properties here are similar. Plus r over n to the nt power. All right, and we said that p is the initial value. We said that r is the rate divided by 100, and n is the number of times it's compounded. And t is time. So if we fill those pieces in exactly the way they're written here, okay, this shouldn't be that bad. So we're going to have y equals 2,000, 1 plus, and then it's my rate divided by 100. So I need to figure out what that is. 9 divided by 100 is 0.09. Okay, so I have 0.09 divided by n, which is the number of times, which is monthly. So you got to know there's 12 months in a year. And then my exponent is nt, so 12x. X is my variable, t could be my variable, whatever you want. So that's our formula. How much of this investment over 10 years? That means x is going to equal 10. Now, the only trouble that people have here is when they plug this in the calculator, they forget that your exponent is 12 times 10. Put that in parentheses. So on the actual calculator, after your caret key, it should say 12 times 10 in parentheses to get the correct answer. Okay, so if you do that and type that in correctly, you're going to end up with $4,902. Oops. Sorry about that. And 71 cents. Exponential web. So still stick with exponentials, complete the web. Remembering here the equation is y equals a times b to the x. So these are multipliers. So we got to try to figure out what do we multiply each time, okay, so that our table grows like that. Now you could use guess and check. You could take 2 times 2 and get 4, times 2 to get 8, times 2 to get 16, but we want 54. So our multiplier has to be bigger than 2. 2 times 3 is 6, times 3 is 18, times 3 is 54. So if I times by 3 each time, I can figure this out. Okay, that's my multiplier. So that's using guess and check. But guess and check only works if it is an integer value. You don't want to guess and check decimals. So we can always do stat, edit, type your x values into L1, your y values into L2, stat, calculate, x reg. Okay, that's the calculator method. There's still yet another method. If we have y equals a b to the x, and we know two coordinates, 1, 2, and 4, 54, we can plug those in for x and y. So 2 equals a times b to the first, and 54 equals a times b to the fourth. And then I want to use maybe substitution method to solve this system of equations. So what I'm looking at here is maybe solving for a. All right, so I would, to solve for a, I had to divide by b. So a is going to equal 2 over b, and then I plug that in to my other equation for a. So I have 54 equals 2 over b times b to the fourth, which means 54 is going to equal 2, and then b to the fourth over b cancels, so I get b to the third. Divide by 2. Okay, so what I'm going to end up doing there is having 27 equals b cubed, and then I need to take the cube root of both sides to get 3. Once I know that b is 3, I can plug that back into one of my originals. So I have a times 3 equals 2. So I need to go backwards 1, divide by 3. So I get 2/3 as my a value. So the equation ends up being y equals 2/3 times 3 to the x power. The graph would look something like, rough sketch. And you can plot some points from your table. All right, so we have 6, we have 18. All right. And then situation, you want to say something that starts at 2/3. All right, or you don't have to say starts at 2/3. You could say on day 1. Probably make it easier. So you could say something like day 1, Jared has 2 rabbits. and they multiply by 3 per month or per day or whatever. Sequences. Consider sequence 2, 8, blah, blah, blah. If it's arithmetic, the next 3 terms. So arithmetic means 2 and 8, we're adding 6, so we keep adding 6. So we'll have 14, 20, 26. Write the rule. Okay, so remember the rule is just mx plus b. mx plus b. M is growth. B is figure 0. So the growth is 6, so y equals 6x. And if you go backwards one time to get your 0 term, you'll get -4, -4. If it's geometric, list the next 3 terms. Geometric means multiply. So 2 times 4, okay, is 8. All right, so times 4 again is 32. Times 4 again is 128. Times 4 one last time is 512. All right, now write the rule. Y equals a b to the x. So it's just like an exponential. A is figure 0, so we got to go backwards 1 and divide by 4. So 2 divided by 4 is 1/2. The multiplier is 4. So 1/2 times 4 to the x power ends up being your equation. Again, you still have the option to do stat, edit, x values in L1, y values in L2. So this will be my x value, 1 and 2. This will be my x value, 1 and 2. Okay? And then this would be stat, calculate, linreg for linear regression. This will be stat, calculate, xreg because it's exponential regression. Investigating functions. So last one, x squared minus 4x minus 5. You use a table for that. We want x-intercepts. We want y-intercept, vertex. Okay, we want domain. We want range. Is it a function? Okay. Does it have any symmetry? So that'll give us a pretty good start here. All right, now there's a couple different ways you can go about doing this. All right, you could change it to graphing form. Well, this tells you the y-intercept right here. Y-intercept is -5. I could plot that point a while. Of course, you don't have to do any of this. You can use a table in your calculator. I could write it in graphing form, okay, by dividing this number by 2. 2 squared is 4, but I want -5, so I have to subtract 9 to get that. So right 2 and down 9 is my vertex. Since it's a parabola, it's going to work out evenly, so there will be another point. X-intercepts, I could factor, so this is vertex form. X-intercepts, I could do factored form. So I'm going to have -5 plus 1 for that. So that means I'll have an x-intercept of 5, 0. Another x-intercept of -1, 0. 1, 2, 3, 4, 5, 0, -1, 0. And that gives me my sketch. I can fill in all these pieces here. I just did x-intercepts. I have my vertex, 2, -9. Domain for parabolas is always all real numbers. Range is always the lowest or the vertex to infinity. So we have -9 to infinity. Yes, a parabola is always a function. And yes, it has symmetry where x equals 2. So you could write x equals 2. You could draw a dashed line of symmetry if you wanted to. Either works. I will tell you this, that the one on the test is an absolute value, which works almost exactly the same as a parabola. And good luck.